Hello, this is Mr. Stansbury. I'm going to take you through the notes on the unit circle. Okay. At the end of this, you should be able to say, I can state and calculate units in terms of sine and cosine, and I can evaluate trig ratios. Okay. So first thing we want to do is take a look at the unit circle. Okay. The unit circle is a circle with a center at 0, 0, just like this here, and its radius is 1 unit. So the distance from here to here is 1, distance from here to here is 1. That's 1, that's 1. In fact, any point from the middle to any point on the circle is always going to be a distance of 1. This is called a unit circle. Okay. The equation of this circle is going to be x squared plus y squared equals 1. And I want to just kind of show you a quick little demonstration as to how that works. So let's say if here's our middle, and then let's say we go to this point right here. Okay, so here's our radius. That's a radius of 1. And then if we make this into a triangle here, go down to this here, and this goes over to here, let's say. This we know is a right angle because we just made it into a right angle, dropped it straight down. Okay, so this distance here is 1. There's 5 of these squares in here, so each one of these is 0.2. So this distance here is 0.8, and this distance right here is 3 of those, so that's 0.6. Okay, so we know that with any right triangle, we can do a squared plus b squared equals c squared, right? So we have a squared plus b squared equals c squared, which really is kind of what this is here. So let's call this x distance our a. So we got 0.8 squared plus our b, which is this height right here, which is the y in this case. So that's 0.6 squared. That should equal 1 squared. So we know that 1 squared is just 1. And then 0.8 squared is 0.64. 0.6 squared is 0.36. And if you add those together, guess what? You get 1 equals 1. Okay, and that's just a little demonstration why the unit circle is so kind of handy and helpful. It just makes it really easy with our ratios that we're going to look at later on. But a squared plus b squared equals c squared will work really kind of nice with that one. Okay, now if p here, there's point P, is any point on the unit circle such that O to P makes an angle. We call that theta. Any unknown angle is called theta, or just an angle. Measured anti-clockwise. Okay, they're gonna. Our book mentions anti-clockwise a lot. That means counterclockwise. So starting from, you always measured anti-clockwise from the positive x-axis. So what that means here is this right here, this red line, this is always our starting, that's where we always start from to measure an angle. So we'll start here, and we go up to there, and that's going to be this angle right here. Okay? Now, if you look on this, cosine of theta, if you remember our dear friend SOHCAHTOA, right? Sine, oops, that was kind of glitchy. SOHCAHTOA. If you remember, cosine here is adjacent over hypotenuse. Sine is opposite over hypotenuse. Okay, so cosine, it says, is going to simply just be, cosine theta is going to be the x-coordinate of this p value right here. Cosine is adjacent, which is going to be this x value right here, over hypotenuse. So really this is going to be x over 1, which just gives us x, right? So that's why they're saying cosine theta is simply going to be just the x-coordinate of p. Okay, and the same idea here, sine is the opposite. In this case, this distance here, y over 1. So you take y over 1 and you get just plain old y. So that's why sine is always going to simply be the y-coordinate of p. Okay, and this is on a super important on a unit circle. Okay, so this distance here has to be 1. Okay, and also this written, yeah, it's basically going to be a ratio, so this is going to pretty much always going to be true here. Okay, so then that will also show, then we know that if cosine is the same thing as x, so we have this info here, which we just proved over there. So what we can do is cosine is going to be the x-coordinate, so wherever I see x, I'm going to put cosine. So now I'm going to say, oh, that's cosine squared. And then it says sine is going to be the y-coordinate, so there's our y. So cosine squared plus sine squared is going to equal 1. And that's where this formula comes from. It's the exact same thing as that right there. Okay, and this is going to come in handy a little bit later on with some other information that we're going to use. Okay. All right, next thing we're going to do is we're going to fill in this chart. And to do that, it's going to be really handy to have this, have these little triangles here so that we can get this all filled in. Now, just to make this a little bit easier with what we're going to end up in here, I'm doubling everything. So instead of the unit, because this is going to be, these are always going to be our hypotenuse. I don't know. These are always going to be our hypotenuses here. But I'm just doubling them. It's going to make it a lot easier when we go through to figure this out. Okay, so if you remember this here from, if you take this and you double it, you add this over here, this is going to be 2, and this is going to be equilateral. So these will all these sides will be 2. This is 30, this is 60, right? And this is 90. So this is exactly doubled, so that means that this length right here is going to be 1, okay? So we got this side is 1, this is 2, so if we do our good old a squared plus b squared equals c squared, we can do, so let's see, the important part is that the c always has to be the hypotenuse, right? So this is 2 squared, and let's just call this a over here, so we'll do a squared, we don't know what that is, plus 1 squared equals 2 squared, right? So we get a squared plus 1 equals 4. We subtract 1 from both sides. A squared is 3. We square root both of those, and we get that a is the square root of 3. So this length right here is going to be square root of 3. Okay. This one here is isosceles triangle, right? Because this is 90, this is 45, this has got to be 45. So we know that these two side lengths have to be the same, so we just have to find one or the other. So we can still do a squared plus b squared equals c squared, but we know that these two sides are the same, so I'm going to just turn this b squared into another a squared, so we'll do a squared plus a squared equals c squared, and then just start plugging our stuff in here, right? So we don't know what either of these are, but we can, a squared plus a squared is going to be 2a squared, and then our c squared is going to be 2 squared, which is 4. So 2a squared equals 4. Divide both sides by 2. A squared, a little hard to read, sorry. A squared equals 2. We square root both of those, and we get that the a side here is going to be root 2. So this is going to be root 2, and this is also going to be root 2 because it's the exact same. Okay? And then this one here, we got 90, 60, and then this is 30. This is the exact same triangle as this, just reoriented. So the short leg is going to be 1, our hypotenuse is going to be 2, and the long leg is going to be square root of 3. Okay, hopefully you'll remember some of that from geometry. Okay, let's take a quick little comedy break before we continue on here. Okay, all right, so here we go. Sine theta. I'm just going to pull up another little graphic here to kind of help us better understand this. Okay, so here's our, let's just picture our, all of our triangles fitting in over here. So here's our x-axis. Here's where we're always going to start, right? So that's at 0. That's the blue line, goes with 0, and it's also where we end at 360. So there's 360. Here's 90 degrees right there at 90. Here's the green at 180, and here's the yellow at 270 degrees, okay? So now, if we picture like sine, we know is going to be the opposite side over the hypotenuse, right? So really, if you picture this here, this over here, this opposite side, if we go straight out here, it really doesn't make, it just makes a line, doesn't make a triangle, but there is no opposite side, so that's going to simply be, oops, let's see, I believe we do this, there we go, that's going to be 0, okay? And then if we go to 30, that's this triangle right here, right? So opposite over hypotenuse is 1/2. 45 here, I'm going to rewrite in here. So 45 is root 2. Opposite over hypotenuse is root 2 over 2. Okay? Hopefully this is looking a little familiar from geometry. And then 60, we've got as opposite over hypotenuse root 3 over 2. Okay? And then for the 90 degrees, that's straight up. Okay, so this length right here from here to here is 1. And this here is also going to be 1. So it's really 1 over 1, which is going to be 1 for sine of 90. Okay, now 120 is going to be from here around to here. So it's going to end up making this, we call this a reference triangle right here. So it's going to go around to this. So basically it's this 60-degree angle again, right? Opposite of that's root 3. Hypotenuse is 2, root 3 over 2. So this is going to be root 3 over 2. Now before I do that, I'm just going to erase this here because we're going to use this chart later. But we end up with root 3 over 2. Okay, and then 135 is going to be this 45-degree angle right here. So we'll use this, root 2 over 2. And then at 150 is going to be out here. So that's going to be just 30 degrees more, and we'd be down to the down to flat here. So we'll use this here, and that's 1 over 2. Okay, and then at 180, we're basically the same thing as over here, except for now we're going negative. But we are really going over here. Our height here is 0, right? So that's going to end up being 0. Now, I purposely left some stuff off in here just because it's going to be a little bit easier to talk about in a little bit. But really, if you'll notice here, this, like say here at 120, this is the opposite side. Sine is opposite over hypotenuse, right? This opposite side here is still got a height of root 3 over 2. So actually nothing has changed here yet. But now once we go down here to 210, okay, now down here we do opposite side over hypotenuse. This opposite side here is just, it's just the same 30-degree angle here, but it's 1 over 2. But it's important to note that this 1 is now going down, so it's actually negative 1/2. Okay, and then 225 is going to be this 45-degree angle here. And go back and take that out so that we again can use that chart here later. Negative 1 over 2. This 225 is going to be root 2 over 2, but it's going to go down root 2 over 2. So it's negative root 2 over 2. Okay. Now, important to note is, look, I don't know if you noticed way back over here, but look, we actually have like this little mirror image going on. So once we got to 90, look, root 3 over 2, root 3 over 2, root 2 over 2, root 2 over 2, 1 over 2, 1 over 2, 0, and 0. And then this every line here is really kind of a little mirror image. So look, 0, 1/2, 1/2, root 2 over 2, root 2 over 2, not counting the signs. So this next one over here is going to be root 3 over 2. And this next one here is going to be 1. And then once you get to this little one of these lines here, 0, 90, 180, or 270, then you stop and start reflecting again. So root 3 over 2. And we'll worry about the signs here in a second. And then that's root 2 over 2. And then this is 1 over 2. And this is 0. Okay? Now, if you'll notice, everything over here, everything here, the opposite sides here, all these triangles that we're making here are all going to be positive from 0 to 180. So look, 0 to 180, all of our numbers are positive. And then after that, all these down here, these opposite sides are all going to be negative. So from after 180 all the way through, all of those are going to be negatives. Okay? So get rid of that again. So these are going to actually all be negative numbers. Okay, very similar idea with cosine. Now we're doing the adjacent over hypotenuse. So here at cosine of 0, this adjacent side, this length right here is actually 1, and it's a distance of 1, so this is going to be 1. Okay, for root 30, it's adjacent over hypotenuse, so it's root 3 over 2, and these are going to be positive here. And then on the 45, it's root 2 over 2. And then on the, let's see, on the 60 here, we've got 1 over 2. And then all the way up here, this adjacent side here is 0. There's nothing there. It's 0 over 1, which is just 0. Okay, and now we've reached our reflection point. So now we can just start copying this down over here, and then we can go back in at the end and figure out which ones are going to be negative. So this is 1/2, root 2 over 2, root 3 over 2, 1, and then we've reached 180, so we start reflecting again. Root 3 over 2, root 2 over 2, 1 over 2, and 0 we're at, again, another one of the axes, so we start reflecting again. 1/2, root 2 over 2, root 3 over 2, and 1. Okay, now we got to figure out which ones are negative. So if you remember cosine, that's this over here is going to be positive. This over here is going to be negative. So 0 to 90, all positive. So those are all positive. From 90 all the way around to 270, those are all going to be negative. So all of these here from the 120, well, from 90 over to 270, these are all going to be negative numbers. And then back over here, we're back into the positive. So these will be positive also. Okay. So here's something that can make this even possibly a little bit easier. And this is the last thing, since we're running really long on time here, but this is fairly important. The sign, like positive or negative, over here in this first quadrant right here, in this group here, for sine is positive, cosine is positive. Okay, I'm going to get rid of these here so it doesn't distract us. And then for over in the between 90 and 180, sine is positive, cosine is negative. Okay, between 180 and 270, that's this group right here, they are both negative. And then over here in this last one, sine is negative, cosine is positive. Sine is negative, cosine is positive. Okay, so there's a nice little pattern here. And both of them are positive here, both of them are negative opposite. And then sines are positive up here from 0 to 180. Cosine is negative. Sine is negative from 180 to 360. Just kind of a nice little pattern here. That could be helpful, might not be. But anyway, all right, we're going to use all this lovely information as we continue on in this chapter, in this unit. If you have any further questions on any of this, please feel free to ask. Thanks.